Does print orientation affect stiffness? In the 3D printing community, it's common knowledge that layer orientation affects print strength, but just how much does it affect flexibility? Today, we're going to be taking a look at that. Starting off, we're going to print out 2 test samples with the settings listed on the screen. Now that those are done, let's put on the test rig and gather our data. The first test will be with the layers in the horizontal plane. Underwhelming, but it tells us a lot. Here's the data collected during this test. I know it's a lot of numbers, but to put it very simply, it means that to bend this test sample in this orientation 1 millimeter, it takes on average 53.05 newtons of force. So how does that compare to a test sample that's been flipped 90 degrees? Well, let's take a look. So once again, here's the first sample, which takes on average 53.05 newtons to bend 1 millimeter, giving us a bending modulus of 1,326 megapascals. And here's the sample that's been flipped 90 degrees so that the layers are in the vertical axis. 69.87 newtons to bend 1 millimeter, or a bending modulus of 1,746 megapascals. That is a 31% increase in stiffness for simply turning our test sample 90 degrees, which is honestly a lot more than I expected. Overall, while I don't think it's enough that it should dictate your entire design philosophy, it is something that you may want to keep in mind for when you're designing parts that you need to be as stiff as possible. And now that you're a tiny bit smarter, let me know if there's something in specific you want to see tested in the future. I've been your host, Kat, and I will see y'all in the next one.